NASA is not just going back to the moon, they are planning to stay there forever. This moment feels historic and unsettling at the same time. Unlike 1969, when astronauts planted a flag and returned home, this mission is about building a permanent human presence, a base that will operate continuously on the lunar surface. The stakes are no longer symbolic, they are strategic. This mission could decide who controls the moon in the next decade. But the real story is not the base itself, it is the transformation of NASA into something far more aggressive and focused. So how will NASA actually build a moon base, and why did it suddenly change its entire strategy? For years, the Artemis program struggled with delays, rising costs, and unrealistic timelines. Many believed it might never succeed. At the same time, another powerful force was emerging. China was developing its own lunar ambitions and moving forward with steady progress. This created a silent but intense competition. So what changed inside NASA, and how are they planning to win this race? To understand shift, we look back at the Apollo era and what followed. The first major shift in the plan is both surprising and strategic. Artemis 3 will not land humans on the moon. Instead, it will operate as a full-scale test mission in low Earth orbit. At first, this sounds like a step backward, but in reality, it is a critical correction. The original plan required astronauts to jump from a basic test flight directly into a complex moon landing using an unproven system. That level of risk was simply too high. Now the mission focuses on safety and validation. The Orion spacecraft will rendezvous and dock with the lunar lander in orbit. Astronauts will transfer between vehicles and test life support communication and propulsion systems. This controlled environment allows engineers to identify problems early and fix them without risking lives. At the center of this mission is a high-stakes competition. Two powerful companies are building the future of lunar landers. One is developing a massive, fully reusable system, while the other is designing a more traditional but highly advanced lander. The new rule is simple, only execution matters. Contracts and promises no longer guarantee success. Whichever team proves their system works first will earn the right to land astronauts on the moon. This creates intense pressure. Even companies that were once considered leaders are now under scrutiny. Deadlines are tight, and expectations are higher than ever. This competition is not just about technology, it is about speed, reliability, and real-world performance. Another dramatic change is the speed of the program. Artemis 3 is now targeted for the year 2027. Shortly after that, Artemis 4 will attempt a human moon landing in early 2028. Then comes an even more ambitious goal. Artemis 5 will follow within the same year. This creates a rapid sequence of missions happening every 6 months. This pace is not accidental. It reflects a return to an older style of operation where progress happened quickly and consistently. Faster missions mean faster learning. Mistakes can be corrected in real time. Success can be repeated and improved. This new tempo signals that NASA is no longer willing to wait years between major milestones. Perhaps the most important decision is the cancellation of the planned lunar orbiting station. Instead of building infrastructure around the moon, the focus is now entirely on the surface. Resources that were once allocated to orbit are being redirected to building a permanent base on the ground. Hardware that has already been developed will not go to waste. It will be redesigned and reused as part of the moon base itself. This shift simplifies the overall architecture. It removes unnecessary complexity and focuses every effort on one clear goal, establishing a human presence on the lunar surface. And this is where the real plan begins. Building on the moon is extremely difficult. The environment is harsh and unforgiving. Unlike Earth, the moon experiences 2 weeks of continuous sunlight followed by 2 weeks of complete darkness. During the dark phase, temperatures can drop below -200 degrees Celsius. These conditions can freeze equipment and destroy critical systems. Machines that stop working in this environment may never recover. Every mission carries the risk of failure. Every mistake can cost years of progress. But there is another layer of tension. Another nation is also moving forward with its own plans. This is no longer exploration. It is a space race. The stakes are higher than ever before. Behind all these changes lies a clear and structured plan. NASA has divided its mission into 3 distinct phases. Each phase builds on the success of the previous one. The first phase focuses on testing and access. The second phase develops infrastructure and power systems. The third phase establishes permanent human presence. This is not a vague vision. It is a detailed roadmap designed to turn an impossible dream into a working reality. Every mission, every system, and every decision now fits into this larger strategy. For the first time in decades, the path forward is clear and achievable. Phase 2 begins in the year 2029 and continues until 2032. This stage focuses entirely on building the physical foundation required for a permanent presence on the moon. The goal is no longer testing, but construction. Large-scale excavation machines will arrive on the lunar surface. These machines will dig trenches, level uneven terrain, and prepare the ground for future structures. Power becomes the most critical requirement at this stage. Solar panels will be deployed on elevated structures to capture maximum sunlight during the long lunar day. However, sunlight alone is not reliable. This is why nuclear power systems will also be introduced to provide continuous energy even during long periods of darkness. Together, these systems create a stable and dependable energy network. One of the most important innovations during this phase is the introduction of a pressurized rover. This vehicle is not just a transport system, it is essentially a mobile living space. Astronauts will be able to live and work inside it without wearing bulky spacesuits. This allows longer missions and more efficient operations. The rover will travel across the surface, carrying tools, equipment, and materials needed for construction. Step by step, the process becomes clear. First, machines prepare the land, then power systems are installed, and finally mobile units support human activity. This method reduces risk and increases efficiency. It transforms the moon from a hostile environment into a manageable worksite where real progress can happen. Phase 3 begins after the year 2033 and represents the most ambitious stage of the entire mission. This is where humans begin to live on the moon for extended periods of time. Instead of short visits, there will be a rotating crew system. Astronauts will stay for several weeks before being replaced by another team. The base itself will consist of multiple connected habitat modules. These modules will function like rooms in a house, each serving a specific purpose, such as living, working, or conducting experiments. Together, they form a stable and protected environment. This marks the transition from exploration to settlement. The moon is no longer a destination, it becomes a place where humans can stay and operate continuously. Long-term survival on the moon depends on using local resources instead of relying entirely on Earth. This concept is known as resource utilization. Scientists plan to extract water from ice deposits found in permanently shadowed regions. This water can be separated into oxygen for breathing and hydrogen for fuel. This reduces the need for constant resupply missions from Earth. Another key innovation is three-dimensional printing using lunar dust. The dust will be heated and transformed into solid structures that can be used to build walls, roads, and protective layers. This approach allows the base to expand over time using materials that already exist on the moon. It is a self-sustaining system designed to support human life in an extreme environment. When viewed from a larger perspective, this mission is about much more than the moon. It represents a shift in global power and technological leadership. The nation that successfully establishes a permanent presence on the moon gains a significant advantage in future space exploration and resource control. But beyond competition, there is a deeper purpose. This mission has the power to inspire a new generation of scientists, engineers, and explorers. It shows what humanity can achieve when it sets ambitious goals and works together to reach them. The real goal is not the moon, it is the future of humanity. NASA has changed its strategy, embraced faster missions, and developed a clear plan to build a real moon base. What once seemed impossible is now becoming a step-by-step reality. But this is just the beginning. The next phase could transform the moon into a fully developed human settlement. If you want to see what a real moon city will look like, watch the next video. Thanks for watching.